Okay, so with 5.4 day 1, this was Friday. What did we learn on Friday? The derivative of e to the x is
e to the x.
e to the x. And it only gets more complicated when you have something in the power other than e to the x. So that means that the antiderivative of e to the x is also e to the x. Now when we're integrating, remember, we got to have our plus c. Okay. So because the derivative of e to the x was e to the x, you take the integral, also e to the x. And again, the only time it gets more complicated is when your power is something other than x. Now, when we did derivatives, we kind of used the chain rule to multiply by the power, or the derivative of the power. Now here, we're going to use u substitution. It's going to be even easier. Okay, remember there is a u substitution that applies to derivatives, but I haven't really taught y'all that. So when you think u substitution, it's because we're integrating. Okay, you shouldn't really be doing u substitution on derivatives. There is a strategy of doing that, but I try to keep things separate so that it's easier to remember. So looking at problem number 1, we're integrating. It's not a simple integration problem, so my only real tool here is to do u substitution. So what is making this complicated? Yeah, there's an extra x in here, but mainly the power, right? That negative x squared. So that's what you're going to let u equal. You're going to let u be that messy power on u. Okay, so then what would du equal? Negative 2x dx. This dx is important. Don't leave it off. Okay, so what we're really looking for here is where is x dx in this problem? Oh, I didn't really want to do it like that. Just try to make it like a highlighter. So there's x and there's dx. I'm kind of going back over this because some of you, I think what you're doing when you do u substitution, it's kind of like you're throwing everything into a pot and then you're just hoping that it all comes out to be something magical. Okay, it's actually more scientific than that. So when you have a number in front, that number goes out to the very front. Okay? This x right here and this dx, they're going to be replaced. So we know we're going to divide over that negative 1/2. And I know eventually that's going to go to the front of the problem. So I'm going to go ahead and do that. If you want to do that as a second step, that's fine. And now, again, I have e to this new power, e to the u. And if you're not sure what else should be over here, go back and look at the problem. This x and this dx, they're being taken out. Those are the only things that are left, and we need to replace them with du. Specifically negative 1/2 du, but we already moved the negative 1/2 to the front. Okay? So then we've got negative 3/2. That's an ugly looking too. I'll redo that. And what is the antiderivative of e to the u? E to the u plus c. Okay, so it's not like I just got tired of the integration symbol and stopped writing it. I did integrate. I did take the antiderivative. It just is itself. That's how e to the x and e to the u work. And then the only other thing you're going to want to do is, yeah, put the x back in. So then that would be negative x squared. And there's no need to simplify here. Some of you might be thinking, oh, we can use some property. Well, you're probably thinking of a log property, and you don't want to do anything to make your right answer wrong. So if you're ever going to simplify, you need to be sure you're doing that right. Okay, so now let's look at problem 2. So just kind of going along with what we did on number 1, what do you think u should equal?
2 over x.
2 over x. Now I'm going to go ahead and write that as 2x to the negative 1. Because that's the same thing as 2 over x. And I'm writing it this way so that du is easier to deal with. Okay, so what would du be?
Negative x dx.
Negative 2
Sorry.
x, and then we got to subtract 1 from the power, dx. We know we're going to divide over that number, okay? So I'm going to go ahead and write that in front. But the question is, okay, how does the rest of this work out? Again, you don't want to just say, I think it's this. If you can know it exactly. So this e to the 2 over x, I know that that's going to be e to the u. There we go. The question is, okay, is this and this the same? Yeah, the negative exponent means we have a denominator. So I'm taking this out, and I'm replacing it with negative 1/2 du. And I already put in the negative 1/2, so all I got to put down is the du. So at this point, it's very similar to problem 1. Now I just got to integrate e to the u. Remember, we integrate e to the u as e to the u. You don't need to add 1 to the power or anything. E to the x, e to the u, they're different. They kind of follow their own set of rules. And that's because e is a number. It's not a variable. And then we just go back, and in place of u, we go ahead and write. You could either write 2x to the negative 1, or you could write 2 over x. It wouldn't matter. They mean the same thing. I'm going to go ahead and write it as 2 over x because that's how you're going to see it on a multiple choice.
This is all the quiz.
Mm-hmm. Yeah, and we are going to review a little bit before the quiz because the quiz is short. But okay, so a lot of problems, that's as complicated as they get. Now, we did 2 where I think finding u was pretty obvious. So now we're going to work some where maybe finding u isn't as obvious. So 3, there isn't a messy power. It's just e to the x. Okay, so you're not going to let u be x. Look, u's never x, because if it was, then you didn't need to do u substitution.
Yeah.
Okay, so let's try that, because that's what we did all last week, was we let u be the denominator. And you know this is good when du is there in the problem. So here, derivative of 1 is 0. Okay, so I skipped that. Derivative of e to the x is e to the x, and then dx. Now technically each time, I'm just pointing this out now to help you with your homework. Technically I should be saying times 1. I should be saying times 1 because the power on the exponent, we need to multiply by that derivative. But we don't need to do times 1. And I bring this up because on your homework, you're going to have a lot of stuff like this where there's a negative in the power. Okay, so if this was basically, what is the derivative of e to the negative x? Yeah, e to the negative x times negative 1. Or negative e to the negative x. Okay, you'll have some time to ask questions about that. So I thought I'd go ahead and put that out there. So there's no number to divide over. And what I'm hoping is that this on this side is exactly what I have in the problem. And it is. Again, that's how you know you did this right. If that doesn't match up, then you probably didn't let u be the right thing. Okay, I have bounds on this one, so I need to change the bounds as well. Right now, these are x equals 1, x equals 0. I need them to be u numbers. So I'm going to plug them in to my u expression. And if you can simplify easily, go ahead and do that. If not, that's okay. So 1 plus e to the 1, that's just 1 plus e. You can't do anything else to that. But 1 plus e to the 0, what is that? 2. Why?
E is 0 is 1.
E to the 0 is 1. Okay, so when I go and rewrite this, my new bounds then are going to be 2 down here and 1 plus e. And let's just do a quick check and make sure that the upper bound is bigger than the lower bound. Do y'all remember what e is? What number it's about? 2.7 something. Okay, so 1 plus 2.7 something, obviously that's bigger than 2, so we're good to go. The u, we remember we let this be the denominator, and then the e to the power of x dx, that is our du. You could put du in the numerator. I think it's easier to put it off to the side because that's just how we always do it. All right, now this is review from last week. What is the antiderivative of 1 over u? Natural log of u. And I'm going to use my new bounds. Don't go back to x and use your new bounds. If you go back to x, meaning if you plug 1 plus e to the x back in, then you got to go back to your old bounds. You've either got to be in u or be in x. So then I would have natural log of 1 plus e minus natural log of 2. And that is your answer. Do I really need absolute value bars around 1 plus e and 2? No, because those things are positive. It's definitely not wrong to write them, though. Okay? Mm-hmm.
Why did you get it 1 plus e when you're switching values?
Because I'm using this expression. So if u equals 1 plus e to the power of x, and x is 1, like e to the power of 1, that's just e. And so that's why, like, if x equals 1, then u equals 1 plus e. If we had had a 2, let's just say there was a 2, I would do 1 plus e squared.
Oh, okay.
And if it's 3, it'd be 1 plus e cubed. And you could definitely plug this into your calculator and get a decimal number. I'm not concerned with that. This is the answer I want. I want you to be able to do this without a calculator. You don't really need one anyway for these numbers. Okay? All right, so let's look at the last example we have here, 4. Again, like any other integrating problem, you got to start off with the correct u. Something to think about is whatever you let u equal, you've got to be able to take the derivative, and that's got to be there. So could u equal cosine e to the x? Why not? Yeah, the derivative of cosine is negative sine, and that's not there. And I can't TOCO that one, okay? That would be too hard to even create. And so what do you think u should be? E to the x. So let's try it. Then du would be e to the x dx, and this works out because I have an e to the x, and I have a dx. Okay? I can take out the e to the x and the dx, and I can replace it with just a single du. All right, and so now we got to go ahead and change these numbers as well. Anytime you have bounds, you need to go get u notation and then stay there. Don't go back to x. So if I plug a 0, I have e to the 0, which is 1. And then e to the negative 1. How else could you possibly write e to the negative 1? 1 over e. I don't really care how you write it, but I just want you to, it may be either way. Anybody read that email that fast? It's quick. Usually I turn off my email. Whoop. Yeah. Here we go. Oops. That's okay. Every now and then when I'm recording like a really important email, like that's about a student comes up, and then I can't use that video like that. But that was just about the fire drill we were possibly going to have today. Okay, so continuing on with this problem. All right, so a 1 goes up here, and e to the negative 1. And again, I would go ahead and see, like, are the bounds in order. If you miss this, it actually works out in the end just fine. But we know that we like to keep the bigger number as the upper bound. So is 1 bigger than e to the negative 1, or 1 over e? Yeah, because 1 over 2.7 is a pretty small number. All right, so cosine e to the x is replaced with cosine u. And remember, these other two pieces are replaced with du. So now I'm ready to take the antiderivative of cosine of u. So before you jump and tell me what it is, I want you to really think, whose derivative is cosine u? Is it sine or negative sine?
Oh, sign.
Are we all in agreement?
Positive.
Man. There you go. Yes, it is sine. It's so easy to get these mixed up. So just when you get to this, just be like, should there be a negative? Should there not? Go backwards, take the derivative, make sure it's all good. So then my final answer here would be sine of 1 minus sine of e to the negative 1, which is really messy. But I can't evaluate, and that looks like a little negative there, but it should not. So I'm going to fix that. You can't evaluate these without a calculator. So we're going to leave it like that. Okay, so again, I want you to notice, 1 and 2, I had a plus c because those were indefinite. They didn't have bounds. And I had to go back to x on those. 3 and 4, these had bounds. I changed the bounds. I stayed in u. Those are mistakes that a lot of people made on the quiz from last week that could definitely be fixed. Okay. All right, here's what I would like for you to do. Oh, I'm going to stop the video first.